Hi, today I'm talking about LeetCode problem 1328-1328, break a palindrome. As you can see, we get a pretty fast result here, although I don't know if that's just a random result from LeetCode. But what this problem asks you to do, it's going to give you a palindrome, a string that's a palindrome, and recall that a palindrome is written the same way forwards and backwards. And what it wants you to do is replace just one character in the string such that your result is no longer a palindrome. And they want you to replace the character so that your result string is the lexicographically smallest possible string that isn't a palindrome. So this question, I think, is kind of odd because once you understand it, it's very simple. But let's just look at this to make sure we do understand it. So here's their example: ABC, CBA. That's a palindrome. And what we want to do is change one letter to make it so that our non-palindrome is the lexicographically smallest non-palindrome you can get by changing one letter. So lexicographic just means it's like the ordering. Colloquially, if someone said, put this in alphabetical order, you would put it in lexicographic order. So A comes before AA. In other words, a shorter string comes before a longer string. And then, it's just in alphabetical order. AB comes after AA. ABC comes after AB. ABD, whatever. If I was putting these things, I'm not saying that this is like an exhaustive list. I'm putting these strings in lexicographic order. If we had the string like A, E, F, and A, D, D, we'd put ADD. Right? Well, I meant to put them in order, but you understand. We're just putting these strings in lexicographic order. So how do we the least lexicographic value would be the one that occurs as high up our list as possible. So this string A has a lower lexicographic value, or it's less than AA lexicographically, which is why it's at the top of our list. This list is kind of descending. So how do we make our palindrome ABC, CBA into the lexicographically least non-palindrome? And the answer is we just change it like this. Like we change the B to an A. And yeah, it's not a palindrome anymore. Basically, we know that when we change one letter, we break the palindrome. And the letter we want to change is the earliest non-A. So you can see that because changing the earlier letters are the most significant. So like we could change one of the letters to a Z, and it would still come. Let me just designate them like this. Designate the lines like this. If we change line 3, the C to a Z, it still comes after 2. Oops, AB. Let me do this. It still comes after 2. 2 and 3 aren't. Maybe I'll just call this like original. And here we have 1 and 2. So variation on original 1 still precedes variation 2. Like changing this second letter is just more significant than changing a later letter, even if you change it by a greater value or by a greater amount. So yeah, basically we look through our list, our word, we look through our string, and we find the first letter that's not an A. So we could change this first letter and break the palindrome, but we're going to create something that's lexicographically later. So what we want to do is find the first letter that's not an A, and then just make it an A. And then we'll have broken the palindrome. Changing a single letter breaks the palindrome. And yeah, we'll be done. So the next thing we would want to think about is what are some test cases we would want to run to kind of pick up if we're covering everything. And it may occur to you that you can have maybe two kind of relevant palindromes. So one is when you have an even number of letters, like you have 6 letters, A, B, C, C, B, A, as in their example, or when you have an odd number of letters, D, A, B, A, D is the example I had, or the test I had. And having an odd number of letters is a different test case because you can't quite just do this paradigm I was talking about, finding the first non-A, because you might have a palindrome that looks like this. So the first non-A would be this B, and if you were to change that to an A, you would still get a palindrome. So you can't quite do that. You have to say it's the first not in the middle character. So you just have to consider up to right before the middle. So if this is a B, you would just consider these two and don't care about this. This letter in the middle can be anything. It could be an A, it could be a B, it could be a Z, whatever. Because if it's right in the middle, it has no partner or no conjugate. So it has nothing that it needs to be the same as. So changing it doesn't break the palindrome. So you would just consider these two, and you would change the first non-A among them to be an A. But this example gives us the case of what if all of our letters are A's? What if we even want to change this string? This is a palindrome, and it could be odd or even number of characters. How would we mess with this one? And the example, or the solution is, if we know there's no first non-A in our first few characters, we know they're all A's. And so then the thing to do is just to change the last letter to a B. Like, it's given to us that this is a palindrome, so it's the same in the first half as it is in the second half. And changing any one character will break the palindrome. So yeah, those are kind of the conditions. Just look at the first up to mid, and don't include the middle if it's an odd number. And then, yeah, if they're all A's, just change the last letter to a B, and you've broken the palindrome. So let's look and see how that's implemented. The first thing I do on lines 5 and 6 here is I just make this check if the length of the palindrome is less than 2. They have a special requirement. If you can't break the palindrome, you should just return an empty string. And of course, if you only have one letter, then you have no way to stop it from being a palindrome. Any single one letter is a palindrome. So that's what I'm doing in lines 5 and 6. I'm just checking for that. In line 7, I'm converting the palindrome string that was given to me as an input into a list. And the reason for that is because I want to change the values, basically. I want to say, okay, give me the letter at the end and turn it into a B, or I want to say, give me the first non-A. I want to just iterate over the characters and change it into an A. So I want to change an individual character. And the easiest way to do that is just to change the value in the list, rather than computing a new string. I guess it's pretty similar, but this just seemed conceptually easy to me. In line 8 here, I'm finding the midpoint. At first I thought I might need to subtract. I don't know why I thought this. But basically what it's doing here is finding the length of my array, finding the midpoint. And actually I don't need to parse this as an int. It would work even slightly better to do integer division. Yep. So we're just getting the midpoint, and recall if it's an odd number, so if len of letters was 5, the integer division of 2 would be 2. Or the same as parsing it as an int, it would be 2.5, and then it would get parsed as an int to become 2. But I think integer division is faster than a regular division and then converting to int, which is why I'll change it to this. And I'll just make sure it still runs. And so then in lines, I guess 10 through 14, I've left this helpful comment for myself. I'm just going to find the first non-A up to the midpoint. And I'm going to find the first non-A up to the midpoint, and then I'm going to change it to an A. So, yep, that's an A. There you go. I'll change that to an A. That's the strategy there. And so we're just looping through from I to mid. If letters sub I is not equal to A, then make it an A. And then we're just going to return our result, because at that point we found it. We found a non-A and we've changed it. So this notation here just creates a string with each of the characters from my letter array. And so if we haven't done that, if we've executed all the steps in this loop without hitting the return statement, that means that the first up to mid is all letter A's. So that means we're in something like this condition. Maybe we have a midpoint that's some other value, but who cares about that? Or maybe we are just all A's. And we're, yeah. So either way, whether we have a midpoint or we're just all A's, we need to break the palindrome by just setting the last letter to a B. We know the last letter is currently an A because it matches the first letter. So we'll just change it to a B. And yeah, here it's just saying the last value in my letters array, change it to a B, and then return the string version of that. Other test cases I did, race car, just because I know it's a palindrome. What if I only had a single A? What if I had all A's? What if I had all B's? The three-letter cases I think are maybe slightly interesting just because they're odd and they're kind of small. Or three of all the same, three all A's. If I was a bit more careful or conscientious, I would have tested up to 1,000 as well. But I knew this was going to be performant enough. Like it seems like a pretty fast algorithm, so I just didn't care about up to 1,000. And 1,000 seems pretty small. So let's see if I still retain 99 percentile for speed, or maybe it's, yeah, that's what I was afraid of. I think it's just a variance in LeetCode that made my first submission seem fast. Let's just run it one more time and see if it's faster or slower. Yeah, it's kind of all over the place. Or maybe another way of thinking about it is for these problems that are only taking like tens of milliseconds, you just can't have a reliable speed because LeetCode has some natural variance to it, and like we're talking about differences of 8 milliseconds. Like this was the 99 percentile result, and 8 milliseconds slower is a 77 percentile result. So who knows? But yeah, I'm going to be trying to solve a LeetCode problem a day. If you like this video, let me know by clicking the like button, say something in the comments. If you want to see me solving and explaining LeetCode problems, feel free to subscribe. Thanks for your time. Bye-bye.